So for polar coordinates, there's a couple important things to remember. How do I go from a polar coordinate to a rectangular coordinate? So for example, if I have the coordinate 3, 45 degrees, and I want to put it into rectangular, what do I do? I want to show you where this comes from so that you remember. 3 is my R value, so it's the hypotenuse of my triangle, and 45 is my angle. And I want to find x and y. Do you remember the cosine ratio? The cosine of 45 degrees has to equal adjacent over hypotenuse. So all we do is we solve for x by taking the R value times the cosine of the angle. And R times the cosine of the angle, 3, this is root 2 over 2. So x is actually 3 root 2 over 2 as a distance. I'm not sure what that is. 3 root 2 divided by 2 is about 2.12 as a distance. So this is about 2.12. So I do the same thing for my y value. The sine of 45 degrees in this triangle is y over 3, opposite over hypotenuse, or y is equal to 3 times the sine of 45, which is also equal to the same thing, 3 root 2 over 2, because a 45-degree angle has both sine and cosine of root 2 over 2. So the big takeaway, whenever you want to convert from polar to rectangular, x is equal to r cosine theta and y is equal to r sine theta. So those are the two important formulas to know. What about from rectangular into polar? For example, what if I had -6, 8 as my coordinate? How do I go into polar? First, you want to figure out which quadrant you're in. -6, 8 is here. We need to find our R value and our angle. So the first step is to use the Pythagorean theorem. X squared plus y squared will give me R squared. Or in this case, 36 plus 64 gives me 100. Pythagorean triple, so that tells me that R would be 10. And then I can use the tangent ratio to find my angle. So the tangent is equal to opposite over adjacent, which in this case is y divided by x. So I'm going to take the tangent inverse of y divided by x. And I want to be in degree mode on my calculator. So I'm going to go second, tangent inverse, 8 divided by -6. -53 degrees, rounded. Is this angle right here -53 degrees? We always write an angle from initial side to terminal side. So this is the angle actually that I'm interested in to get to that position. So I actually need to take 180 and subtract 53 degrees. So that gives me 126 about 0.9. 126.9 degrees. So I write my final answer 10, 126.9 degrees. So when you do your tan inverse, you have to figure out which quadrant you're in and if your angle makes sense from the origin. So our two big formulas, x squared plus y squared equals r squared, and the tangent of theta is equal to y divided by x. Plotting polar coordinates. You always start from the positive x-axis and you think about your angle first. So if I want to go 90 degrees, I'm going in this direction. If my R value is negative, in this case -2, I'm going to walk in the opposite direction from 90 degrees. So instead of walking this direction, I'm going to go straight down and I'm going to go out 1, 2 radii spokes, and there I am. So there's point A. Point B, 5 pi over 6. We need to figure out how many degrees each of these spokes is equal to. This looks like they would be 15, right? So there's my 30, 60, nope, 60, this is 45. 5 pi over 6 is one slice just before 180 because it's a 30-degree reference angle. And I need to go 1, 2, 3 spots in that direction. 390 goes once around, and then it's an additional, 30 degrees? So I need to go to 30 and walk out 4. 1, 2, 3, 4. Here's point C. So how could you write the above coordinates in a different way? So let's use either a negative angle or a opposite R value. So how could I get to that point? Couldn't I just go 270 and then go 2 in that direction? Oops. 270. So polar coordinates can be written in a multitude of different ways using negative R values, different angles, whereas rectangular coordinates, there's only one exact rectangular coordinate for every point. All right, what about this one if I went backwards this amount? This would be 7 pi over 6, right? So I could say I want to go 3, and I want to go negative 7 pi over 6 radians. And couldn't I just call this 4, 30 if I wanted to? Just go part way instead of going all the way around the circle first. There's lots of right answers to those. All right, so now that we've kind of reviewed polar, I'm going to kind of go through the A's and then you're going to try some of the others. So on number 1, 10, 60 degrees, I'm going to use this first conversion formula. I'm going to do 10 times the cosine of 60, 10 times the sine of 60. Cosine of 60, so the chart that you need to kind of remember, if I have enough room up here to write it, that you might want to put on kind of your final exam note sheet. We've got 30, 45, and 60. We've got sine, cosine, and tangent. The sine of 30 is 1/2. The cosine of 30 is root 3 over 2. And the tangent of 30 is root 3 over 3. 45 both have root 2 over 2 as their sine and cosine and 1 as the tangent. And then these flip-flop. So root 3 over 2, 1/2, and then just root 3. So if I'm doing 10 times the cosine of 60, the cosine of 60 is 1/2. 10 times 1/2 is just the number 5. And 10 times the sine of 60, 10 times root 3 over 2 is 5 root 3. So that is my final answer. You can do B. I'd like to skip over to C because I don't want you to do more work than you have to. When it's a quadrantal angle, please don't use this formula. Please just plot the quadrantal point. So in this case, I'm going negative 3 pi over 2, and then I'm going 1. How do I write that using a rectangular coordinate? My x value is 0, and my y value is 1. Don't spend the time to multiply that all out, so you just have to do B on this problem. All right, let's take a look at, I'm going to do C, I think, on number 2, and you can do A and B. So I need to do the Pythagorean theorem. I'm at negative 1 and then positive root 3 over 2. I need to find this R value. So I'm going to do x squared, which is 1, plus y squared, which would be 3/4. And then I have to take the square root of that. So what is this? This is the number 4/4. So I have 7/4, and I'm taking the square root. So R is the square root of 7 over 2. And then I need to do the tan inverse of y divided by x. So the tan inverse, root 3 over 2 is not one of my special values for tangent. Root 3 over 3 would have been. So I'm going to do the tan inverse of, oops, oh, I'll put root 3 divided by 2 in parentheses, and then I'm dividing by -1. Negative 40.9. This is not negative 40.9. So if this is negative 40.9, this is what I'm interested in. So I'm just going to add 180 so I get the supplementary angle. So I need 139.1 to get there. So R is root 7 over 2, and I'm going 139.1 degrees. Quadrantal angle, don't do too much work on that one. And then you've got Pythagorean theorem, and that should be an exact value for that one. Okay, converting from, this should say in polar form. So I'm in rectangular, and I'm going to do what I can to switch into polar form. I think I'm going to leave A for you. That one should be an easy one. B, you are not allowed to square both sides of this equation, because this you'd have to FOIL out. So don't think that this is just like this problem. In B, anytime you see an x, you want to replace it with r cosine of theta. Anytime you see a y, you want to replace it with r sine theta, and then equals 16, and then just leave it. See if you can problem solve on 3a. Hopefully you remember how to rewrite that. And 3c, my hint to you first is to square both sides of the equation before you start. Number 4, rewriting these equations in rectangular form. I'll do A. This is just x equals 2, which is a vertical line. I'll leave you B. I'll leave you E, writing a circle. All right, I'm going to show you how to do C. I can't replace cosine theta unless it's r cosine theta. So I'm going to multiply both sides of this equation by r. R squared equals negative 8r cosine theta. Technically, I could stop there, but I can't identify this graph yet. Oh no, sorry, I can't stop there. Now I need to substitute in squared plus y squared equals negative 8x. So technically I could stop here, but I can't identify this graph yet, so I'm going to go and complete the square and identify the conic. X squared plus 8x equals 0. So I added 8x to this side. To complete the square, I'm going to add 16 on both sides. I'm running out of room. So I have x plus 4 squared plus y squared equals 16. So now I can identify this as a circle. It has a radius of, or sorry, a center at -4, 0. And my radius is 4 because that is r squared. Well, on D, what you're going to want to do is take the tangent of both sides of the equation. So you have tangent of theta equals, what's the tangent of pi over 6? Root 3 over 3. Tangent of theta is equal to y divided by x. So this is just a line. Y equals a slope of root 3 over 3 times x, and it would go through the origin. You try B and E. Okay, so F, we've got we can't get rid of sine unless it's r sine of theta. So we've got a couple options here. I'm going to go and multiply both sides by r. So I have 10r sine theta equals 5r. I can substitute in y. R is the square root of x squared plus y squared. So this doesn't really help us so much, but I'm just going to leave it at that step. It doesn't simplify nicely. A little bit about complex numbers. One class kind of covered complex numbers and the other one didn't. So we're not going to have to convert complex numbers. into polar form on the final exam, but it'd be nice to remember how to do things with complex numbers. One class spent time on this. So when you add complex numbers together, you add the like term. So in this case, 5 plus 2 is 7, and 6i minus 9i is negative 3i. When you multiply complex numbers, you do FOIL. So 2 times 5 is 10, plus 16i minus 15i, and then minus 24i squared. I squared is the same as negative 1, so this is really the positive number 24. So you really have 34 plus I as your final answer for 6B. And on 6C, you distribute the 4, so you'd have 20 plus 40I. And you can do D and E. Make sure you distribute the negative sign. And then you should be able to sketch these graphs. You can use a calculator for reference if you need. You have to put it in polar mode